With that, I'll go ahead and hand it over to Chris.
Hey, thank you. So today I have a slide deck put together. I'm going to go ahead and put a link to that in the chat for anybody who wants access to the links that I'll be sharing today and would like to follow along or use it for reference. We'll also include it in the email that we send out, and it will be in the webinar video that we put on YouTube. So here's that link. And today we're going to be talking about managing dependencies in Airflow. So without further ado, let me share. Awesome. So specifically when I'm talking about dependencies, we're going to talk about dependencies between deployments, which is the largest grain, DAGs, and then also tasks, right? So there's ways to set these dependencies dynamically and between tasks and DAGs, and then using the stable REST API for the inter-deployment dependencies. So we're going to talk about all that. As far as an agenda for what we're going to cover on the task level dependencies, we're going to be covering, how to set basic dependencies, how to set parallel or cross downstream dependencies. Like I said, dependencies for dynamically generated tasks amongst task groups when you're branching, and also how to use trigger rules for when you set dependencies. Cross DAG dependencies, we're going to be reviewing how to use the trigger DAG Run operator today, as well as how to properly use the external task sensor. And like I iterated before, the cross deployment dependencies will be accomplished using the stable REST API available with Airflow 2.0. And I have a working example to show you that today. In this webinar, these are some of the references and some of the documentation that I've pulled in, and these are all clickable links if you have the slide deck in front of you, and if you want to utilize these resources, please feel free. Okay, so let's start at the smallest grain, which would be a task level dependency. So in Airflow, when you have a task, you can set a simple dependency using syntax or a bit shift operator. So this would be like the syntax example. Whoops. This would be the syntax example right here. And then these would be the bit shift operators. And so as you can see over here on the graph view for these, we have first task, second task, third task, fourth tasks. And that's just using, you can set that using d1.setDownstream and then put the downstream task, the variable for the downstream task in that syntax, or you can set up what I like to call a bit shift operator dependency chain. So let's look at this in practice. So let's say that I had a few dummy operator tasks. Great. So from here, I already have a start and finish dummy operator, and I have a simple bit shift operator here ready to go. And so the way that we, excuse me one sec, the way that we set that up is, if this wasn't here, we could say, if we wanted start to be first, T1 to be our next task, and finish to be the next task, we could do it like this. And if we go to our sandbox where this code is being read into and look at our graph view, we can see that we have that start, task one, and finish with arrows between the tasks representing the dependencies between each of those tasks. So what would this look like if we used the other methods? So we've already used the bit shift operator to set dependencies between these tasks, but we could also use the syntax that I talked about, right? So we could say, start, set downstream, and we can say T1, and then T1, set downstream, finish, and so on. Now you can also go the other way. So these are setting downstream dependencies. We could say finish, set upstream, T1, and T1 set upstream, start. So this would accomplish the exact same result. If we go back to our sandbox here and refresh it, as you can see, those dependencies didn't change anything. Now, just like there's set downstream and set upstream, you can also use bit shift operators the opposite way. So we could say instead of start, T1 to finish, we can also say, we can also go like this way. So we can say finish T1 to start. So that's how you set those specific dependencies. And again, like those are all achieving the same result here. Best practice is not to intermingle, right? So I should not, if I'm using bit shift operators, I shouldn't use the syntax. And if I'm using the syntax, I have a request to make the IDE a little bit larger. Let me see if I can do that for y'all. Hang on, I'm gonna actually.
Chris, I think if you're on Mac, you can just command plus and it'll.
Okay.
The text size.
I'm hitting that right now. And it's not increasing the size. Here, I'm gonna pause sharing real quick and figure it out real quick on my menu. And then we can continue.
Sometimes different apps have different methods for doing it, which always makes it fun to figure out.
Yeah. Okay, I think I found it. Let me see if I can just increase the size. There we go. Is that better?
That looks better on my screen, Chris.
Okay.
Yeah, thanks to whoever brought that up.
Yeah, awesome. So now that we've talked about kind of the simple ways to set tasks, dependencies between tasks, let's keep moving and talk about how to set up parallel dependencies, right? And so we've talked about this dependency chain where we have those bit shift operators. Oh, and by the way, I'm going to be using the bit shift operator. I just feel like from a readability standpoint, that's what I prefer. But again, no one way is better than the other. It's really just your personal preference. As long as you just don't mix the two, that would be best practice. So I'm going to be using the bit shift operator. And this is we've set up like a dependency chain so that these tasks are happening sequentially. But if we wanted to have these tasks happen at the same time, you need to put them into a Python array. So let's talk about what that would actually look like. So from here, we have T1. Let's add a couple more of these dummy operators. And let's create an array that has the ones that we want to run in parallel. So from here, I can add this as an array and put in T1, T2, T3, T4. And then put in our finish task. So now looking at what this results in our sandbox, we should see task 1, 2, 3, and 4, and those will all now run after start instead of sequentially. And so that's how you set up a parallel dependency in Airflow. Awesome. So yeah,
Chris, are you able to define dependencies between multiple arrays or lists?
You can. It gets a little bit complex here. The arrays, I think, have to have the same number of tasks in them in order to do that. And there's a couple of tools to help you. There's the chain function, which I can show you right here. So chain is imported from the base operator module. And what it allows you to do is if you call that function and you just say start, T1, T2, T3, T4, finish, right? That's going to be the same exact thing as doing this, right? So chain can help. And with your question specifically, like I said, there has to be the exact same number of tasks in the upstream and downstream array for it to work, or else the dependency, it will get confused. Airflow will get confused and not be able to complete the dependency chain. But I think this should work. Yeah. And so kind of interesting how this works. This is working in parallel. So task 1 and 2 are running in parallel, and then task 3 and 4 is running in parallel. And task 3 is dependent on task 1, and task 4 is depending on task 2. So if you wanted like task 1 to be dependent on 3 and 4, and task 2 to be dependent on 3 and 4, that would actually be called a cross downstream dependency. So we could do that using the cross downstream module. And to see what that looks like, what we do is let's just put T1 and T2 in that same array. And again, they have to have the same number of tasks or it won't work. And if you have 2 lists of tasks or 2 arrays of tasks that you're running in parallel and they don't have the same number of tasks, that's fine, but you just have to put a dummy operator between them in order for it to work. So this on the cross downstream, let me just finish that example real quick to answer your question. And then from here, we can say T3 to T4 and then to finish. I think this should give us a cross downstream dependency. Yeah. So now, as you can see, like in order for task 4 to run, task 1 and 2 are going to have to finish. In order for task 3 to run, task 1 and task 2 are going to have to finish. So they're all dependent on each other. Got a question?
Awesome. Thanks for that.
Yeah,
I think chain and cross downstream are super useful functions for defining more complex dependencies, but not a lot of people know that they're even available. I didn't know that until pretty recently. So yeah, that's super cool.
Awesome. And there's also, I don't have an example for it, but there's also the way is to set like a chain dependency dynamic with dynamic tasks, which is what we're going to talk about next, using that chain function. So it's super powerful. So be sure to check that out. Looks like we have a question. What if any of the task fails in the array? Does the finished task get triggered? That is a super good question. So that does depend on your trigger rules, which we're going to talk about a little bit later. But by default, like if you haven't set any of those trigger rules, then no, the finished task will not trigger because the default trigger rule for finish is all success, meaning that all of the upstream tasks to finish have to succeed in order for finish to trigger. But again, we'll talk about trigger rules and ways that you can go around that. But yes, by default, it will not trigger. Awesome. Okay. So we've gone through parallel dependencies using the chain function and as well as the cross downstream function. Let's jump into those dynamic dependencies and talk about kind of what that looks like and what we mean by like a dynamic set of tasks, right? So as you can see, I've coded out 1, 2, 3, and 4 right here, and that's super repetitious. Let me get rid of the dependency chain. So we can bypass this process by using a for loop in Python. And we can say, for I in range, and we'll say 1 through 5. And then let's just set up a dummy operator, just how we have it here. And this will create those same 4 tasks just the way we have it here. So now I can get rid of these. And this becomes super helpful when you have, multiple tasks that are following the same pattern. Like I've seen dynamically generated tasks, you know, that there's a for loop that's generating, you know, hundreds of tasks as opposed to just 4 or 5, like we have in this example. So if we go back to our sandbox, we can see that we just have each individual task. There's no dependency set up between them. And what we can do here is if we wanted, you know, task 1, 2, 3, and 4 to run in parallel, kind of like what we talked about in the last example, we can actually set that in the for loop right here. So we already have our start and finish dummy operators up above the for loop. They are not being dynamically generated. If they were in the for loop, then they would be generated like 4 or 5 times, as long as you made a dynamic or a unique name for each of them. But in here, to set that dependency between the start and finish, we could put this into its own variable and then just call that in a bit shift operator dependency chain within the for loop. Notice how I'm indented in the for loop here. And I can say start t finish. And from here now, if we go back to the sandbox and take a look at what that looks like, that set up the dependencies for us to have those tasks executing in parallel that were created with the for loop. So that's how you set dependencies in a for loop. Now, as you can imagine, I gave the scenario of these, excuse me. I gave the scenario of, you know, having a for loop that generates hundreds of tasks, and that can make your UI extremely messy and make it very, very difficult to follow task dependencies. And so for that reason, we have the function of task groups. And so task groups, what a task group does is it organizes the tasks so they can be added to the bit shift dependency chain. And so this is just a UI concept, but it allows you to basically put dependencies within a group and then put, you know, connect it to an upstream dependency and then a downstream dependency. So it's a little bit hard to, you know, explain this because it's kind of an abstract concept. So let's just dive in and I'll give you an example of how this would work. So let's just use that same for loop that we have here for these right here. And let's throw this inside of a task group. And notice I do have that import readily available right here. So I'm going to call that import to create a task group. We'll call this with task group ID equals group 1 as TG1. That's what we'll call our task group. And then we need to indent these items. And if we go back to the UI and hit refresh, notice now that we just have group 1, but if we click on that, it expands for us. So that's really nice. So it picked up the dependencies that were set in that for loop, and it's just nested under that task group that we've created. Now, what if you wanted to add additional dependencies within that task group? Well, that's actually really easily done. So for example, let's say we wanted a task to run before those parallel tasks that are generated by this for loop. So let's create a new task. We'll call it my test task. We'll just make another dummy operator. And let's say we wanted my test task to run before, you know, as a precursor to these 4 dynamically generated tasks. So I'm going to get rid of this dependency chain right here. And all I have to do is just say my test task and then throw in that bit shift operator and then T. Now, what about the start and finish? We can still set up a upstream and downstream dependency for the task group as a whole. So now outside, right now I'm outside of the for loop, right? And so what I need to do is get outside of the task group statement as well. And I'm still in the with DAG statement on line 22. But now I can say start, and then I'm just going to call this TG1 variable right here and put that here. And then I'm going to put finish. So now all of the dependencies that I defined within TG1 group will exist within that task group, but then we have the upstream dependency of the start operator, or the dummy operator, that's the start, and then the dummy operator downstream is the finish. So looking at what that actually looks like in the UI, we have the start and finish outside of the task group. And then we have that additional task that we want to run before our parallel tasks run. So that's how you would add an additional task to the task group and make a dependency for it. Awesome. Okay. So jumping into branching, if you haven't used the branch Python operator, you should definitely check it out. So what the branch Python operator does, it works a lot like the Python operator, where it takes a Python function as input, and then based on the result of that Python should result in a downstream task. So and whatever downstream task is returned, that's what portion of the graph it will go down. And so in like a conditional setting, maybe you have business rules that are requiring you to run a specific pipeline and skip another based on whether certain criteria is true or false, right? So, there might be a certain scenario here where, the branch Python operator, which is this pink box right here, returns branch 0, branch 1, branch 2, branch 3, or branch 4, depending on what is going on at the business. And then it will only accomplish, it'll only run that specific task and skip branch. Like in some instances, it would run branch 0 and skip 1, 2, 3, and 4, or, fill in the blank for which one it runs and which ones it skips. So let's look at this in practice and how to set dependencies between like a branch Python operator and then the downstream tasks below it. So again, I do have the imports that I need right here. Here's the branch Python operator. So I'm just going to create a task based off of that. Call it branching. And then we have a Python callable function, just like the Python operator that we use with Python custom functions. And I already have this pre-written function right here that I'm going to call. It's called return branch. So it just takes in an array and returns randomly branch 0, branch 1, branch 2, branch 3, or branch 4. So I'm going to call that one specifically. Provide context equals true. Okay, so now from here, we have the branch Python operator set, but we don't have any downstream dependencies set. So we need, we need about 5 tasks, branch 0, 1, 2, 3, and 4, that would be downstream of this. And the task IDs have to match these right here. So we need to create some dummy tasks real quick. So we'll call this branch 0, which would be the first option. And I could have done this dynamically, but just to illustrate the principle of how this works. Oh, we don't need branch 5, we just need branch 4. Awesome. And let's go ahead and throw those into a Python array so that they run in parallel. Okay. So now we can call our start, which should be the first task that runs, the branching operator, and then downstream of the branching operator, the branches that we want to go down, iterate through, and then finish. And let's look at some of the questions that have come in. So question, can we use the group option on case of cross DAG dependencies? can use the group option on case of cross DAG dependencies. So you can call, we'll get to cross DAG dependencies in a second. We haven't quite gotten there yet. And you could include the two operators that we're going to talk about, which are the task group or the trigger DAG run ID operator, an external task sensor, and a task group. But you can't put two separate tasks and two separate DAGs into the same group. Okay, awesome. And then moving forward, let's go to our sandbox now that we have our branch Python operator set and then the downstream branches set as well. And let's take a look at what that looks like. If you notice, this is the exact same dependency tree that we had in the slide, except it's set up from left to right instead of top to bottom. So if I change from top to bottom, this helps us to see that. Now, just to give some context of how this works, let's go ahead and just run it. So I'm just going to trigger this DAG. Perfect. So let's go back to the graph view. Put it back to top to bottom. And it looks like the Python function randomly returned branch 1. So it chose branch 1 to go down. But if you notice, finish actually didn't finish. It didn't run. And that's because of what we were talking about with trigger rules previously. So trigger rules are set on the task level. And so we would have to set a trigger rule for finish, because right now, finish is expecting branch 0 through 4 to complete as succeeded. Right, where instead branch 0 was skipped, branch 1 succeeded, branch 2, 3, and 4 were skipped. And so with that, we do need, if we wanted finish to actually run, we would need to change the trigger rule. And there are a few different trigger rules available. So if we were to go into into finish, into the finish task, just like this example shows, and set the trigger rule to 1 success, then finish would run in this scenario. But there's a bunch of different scenarios. And like I said, all success is the default, meaning we would need branches 0 through 4 to succeed in order for finish to kick off. But there's also options to set up all failed, which means all of them would have to fail, all done, meaning all of them would either have to succeed or fail, 1 failed, meaning a singular task, upstream task failed, and then 1 success, meaning that a singular upstream task succeeded. Dummy is just to ignore all dependencies. They're just for reference and to trigger anything at will. So the one we're going to use is that 1 success to trigger our finish. So showing what that'll look like, we need to go to our finish task and add a parameter, because we're checking the upstream from the finish. And we just need to add a parameter here for a trigger rule. Call this trigger rule 1 success. Perfect. All right. Going to go ahead and clear this out and rerun it. And let's see if finish actually runs this time based on the trigger rule. Looks like it did. If we're looking at the tree view, but we were referencing the graph view earlier, so let's go to that as well, just for clarification. So it looks like this time branch 2 ran based off of that Python method, and finish did run because we had the trigger rule set appropriately for that specific task. Okay. So that covers our task level dependencies. Let's dive in to our cross DAG dependencies. And now this is where it gets a lot of fun. So we get a lot of questions around like what's best practice as far as like when I should start a new DAG, and should I have multiple DAGs or should I put all my tasks in a singular DAG? And the answer is that best practice is if you have dependencies between tasks, that you usually want to put them all in the same DAG, unless you have DAGs on different schedules or tasks that are on different schedules or that have different owners entirely. So what that means is maybe one team owns one DAG, another team owns another, they run at separate times, and you need there to be a dependency between the two of them. And so the first way to create a dependency between two DAGs, and what I mean by DAGs too, sorry, let me just back up a little bit here. So these represent DAGs, right? So I have 4 DAGs in my Airflow deployment. So if I wanted to create a dependency between DAG 1 and DAG 2 here, the first way and the easiest way to do that is by using the trigger DAG Run operator. And what the trigger DAG Run operator does is it triggers a DAG run for a specified DAG ID. So if I pass in a DAG ID, which is these right here, one trigger downstream DAG would be the DAG ID for this DAG. If I pass that into this trigger DAG Run operator, and as well as an execution date, which is optional. If you leave it blank, it'll just use the current date and time. And then these other parameters, then it will trigger that DAG from a separate DAG. Well, let's talk about these additional parameters and then let's try it out. So some of the parameters that we can include is the reset DAG run. So if the DAG that you're triggering already has a DAG run for the execution date that you are triggering it for, it can just clear that out. Wait for completion. If you have this parameter set, which it's default not set, it will wait for the entire DAG to finish before returning success to the trigger DAG Run operator. Poke interval is set if you have wait for completion set, which that's how often it checks to see if the DAG you're triggering has finished. Allowed states means just the allowed states of the DAG that you're triggering. Like if you're okay with the DAG triggering but having some tasks in it that aren't success, maybe you have some that are skipped. If the DAG returns a different state than success, you can specify that here. Or if you want to specify failed states, that's the opposite to allowed states. So on this, you don't have to worry about most of these parameters. The ones that are required are obviously the task ID and then the trigger DAG ID, and then we can leave the rest blank. I think we'll use execution date as well, but you don't necessarily have to. So looking at what that looks like, let's go ahead and I'm just going to go ahead and delete these. And let's trigger a downstream DAG. And again, I have that operator already imported here, so that's what I'm calling. Call this trigger downstream DAG. And then let's get the DAG ID of the DAG we want to trigger. So in here, this was the one we were saying we wanted to trigger. I'm just going to copy that and paste it right in there so I don't make a typo. And then for our execution date, I'm actually going to set this. Like I said, you don't necessarily have to, but this will help us later when we talk about external task sensors. So I'm going to go ahead and put this in here. And then let's also set up a trigger DAG run operator for the other downstream DAG, which is the 3 right here. So we'll have 2 of them. So this will trigger 2 DAGs from this. We'll trigger 2. Let's see. Can I paste that without the, yeah, there we go. So we'll have 2 DAGs triggering from this singular DAG. This is the DAG ID that we want. And remember, we have to have different task IDs for each task. They have to be unique. So I'm just going to put a 2 right here. All right, so from start, we can go straight to finish. We got rid of all of our dummy operators, so we don't need those. But now I'm just going to put these in a parallel run next to each other. So we can say trigger downstream DAG. Oh, and then I probably should rename the variable as well so that it's unique. And I can say trigger downstream DAG 2. Let's go take a look at what that looks like in the sandbox. Okay, perfect. So we're just going straight to start, finish, and then trigger downstream DAG and trigger downstream DAG 2. So that will trigger DAGs 2 and 3 for us. Now, if we go ahead and run this, then we should see DAGs 2 and 3 get triggered. just clear this out actually. Perfect. So it looks like it succeeded. Let's go back to our DAGs and see how we're looking. So yeah, DAGs 2 and 3 did get triggered by default after DAG 1 was finished. And so we have DAG 3, which already finished, and then DAG 2. Let's go take a look at what's running in DAG 2. So it looks like we have a Python sensor set up here. And I did that on purpose so that we could talk about sensors as we transition to talking about the external task sensor, which is the second way that I wanted to talk about today regarding how you would set up dependencies between DAGs. So a sensor is set up, here I actually stole a definition from the Airflow documentation because it was so good. So sensors are a special type of operator that are designed to do exactly one thing, and that's wait for something to occur. It can be time-based, it can be waiting on a file, an external event, but all they do is wait for something to happen. And then once that thing does happen, the sensor operator returns success, and then the downstream tasks can run. So based on that, we have this check using Python sensor, right? And what this Python sensor is doing, if we go to our DAG2 code, is it's checking this variable. It's using this function to check this variable right here, the path sensor check, to see if it's true. And so looking at that, let's go to our variables. It's currently set as false. So if I change this value to true, then that task that is running currently in DAG2 will finally return as success, and the DAG will finish itself. So how does that relate to what we're talking about now? And the way that relates is we're going to use an external task sensor, which works a lot like this Python sensor that I already had set up, in that the external task sensor waits for a task in a different DAG to complete for a specific execution date. So what that means is you can set up an external task sensor to watch this finished task, and once that finished task succeeds, then the external task sensor itself will succeed and continue the pipeline. And so let's go ahead and set up an external task sensor for DAG 3 that is looking at DAG 2, DAG 2's finished task, right? And then you can see you can kind of visualize what that looks like. So going into our third DAG, let's set up our upstream DAG with an external task sensor. Call this wait for DAG to finish. Say external DAG ID, and this has to equal, this has to be correct, so we'll just copy and paste it in. The external task ID that we're interested in has to be that finished task that runs at the end. And then we can leave allowed states, failed states as the default because we're just wanting it to succeed. And then we're going to set the mode to reschedule. And our timeout. By default on these sensors, it's best practice to have a timeout, because I think by default these sensors will run for a full week before they time out, and that can be very taxing on your environment. So it's always best practice to set a timeout, whatever that timeout is. It's really based on your business and your use cases. So I'm just going to set mine for 30 minutes right now. This value is in seconds, so that's 60 times 30 will give you the number of seconds in 30 minutes. So okay, so let me go grab the external DAG ID of the DAG we're waiting for, which is going to be this upstream DAG. And let's paste that in here. Awesome. So if we go back to our third, we should have this here. We didn't put it in our dependency chain, so let's go ahead and do that. So we want this to run before the DAG starts. So now with that set, we can go to our graph view. And as you can see, that external task sensor will be checking for the finish task and DAG2 to finish before it kicks off the rest of this DAG. So let's trigger our DAGs again and see if this works. So I'm going to go ahead. I'm going to mark this as failed, and I'm just going to clear it out. Actually, you know what? Let's just start from the beginning. I'm going to get rid of all my DAG runs. Have a nice clean slate. Okay, and let's go in so that first Python sensor succeeds. Let's go into our variables and let's just change this to true. That way we don't have to wait for it to succeed. It'll just automatically see that this value is true and keep moving through the pipeline. Okay, so from here, let's go ahead and trigger that first DAG again. It has, again, those trigger DAG run operators in it, so that it will trigger DAGs 2 and 3 for us. Okay, now if we go back to the DAGs, we can see that DAG 2 got triggered. And DAG 3 got triggered. So DAG 3 is not going to finish until DAG 2, the finish operator at the end of DAG 2 is finished. So now that that has been marked as success, this should work. That's strange. I've never seen that before. Did I put the wrong DAG ID in there? Huh. Okay, that was kind of a fluke. I don't know why that happened, but it did find that when I cleared it out, it did register that finish task and the upstream DAG did finish. Okay, so that covers sensors. Now, as far as that, a couple of things that I wanted to reiterate. So the reason why I set the execution date in DAGs 2 and 3 is because when you're using an external task sensor, the task in the separate DAG that you're checking for, the DAG run has to equal the execution date of the DAG run that you're checking for has to equal the execution DAG of the DAG where the external task sensor is running. Meaning, like if you're checking an upstream DAG, but it has a different schedule and is triggered on a different schedule, then the external task sensor doesn't know which DAG run it's looking for. And so you can use, if they are on different schedules, you can use the execution delta parameter to specify the difference in hours or a difference in time between the schedule of your upstream DAG versus the DAG that the external task sensor is located in. And so when I triggered these DAGs and I use this hour rounder function, it basically just set up the same exact time for them so that I didn't have to worry about that. But if you are using this external task sensor again, and there's a different schedule for the upstream DAG that the DAG's running on versus the schedule that the external task sensor is located in, then you'll have to specify that time difference using the time delta parameter or specifying the DAG run or specifying the date time object of the DAG run that you're interested in looking at. So that's another kind of caveat that goes along with the external task sensor. The other thing that is very notable is using which mode you're using. So where possible, try to avoid the external task sensor and use the trigger DAG run operator, because the external task sensor is going to take up, it's either going to put stress on your scheduler or it's going to take up a worker slot, depending on which mode you have set here. So we have the mode set to reschedule, which I would recommend to use as your default. And mainly because if you have the mode set as poke like this, then what that poke is going to do is it's going to continually take up a worker. And if you have too many of these sensors, then it can result in a deadlock because all your workers are busy checking for certain criteria to be true. And then if you use reschedule, the worker that is checking for that criteria is actually released, and the task is put back into the queue and queued up again. But again, that's going to put some stress on your scheduler. It's not going to be as resource intensive as the poke mode, but you should try to avoid using, like I said, you should try to avoid using the external task sensor wherever possible. There's certain scenarios when you'll have to use external task sensors, specifically when you have multiple upstream DAG dependencies. There's no way to really get around that when you have multiple DAGs upstream of the current DAG that need to finish, and you need to make sure that they finish. So there are instances where you're going to need that, and you're going to have to use the external task sensor versus the trigger DAG Run operator. But like I said, where possible, try to avoid it just for the resources that it does take up. Awesome. The last thing that we need to talk about is cross deployment dependencies. Now, here at Astronomer, we have a lot of our clients that rule of thumb is to have a separate deployment per team. And it's becoming more and more of an issue of, how do I set up a dependency between, some of the tasks in a completely separate team versus my team, meaning they have their own Airflow instance of Airflow, and I have my team has my own instance of Airflow. And I need to know when their instance of Airflow finishes, and so that mine can begin, or vice versa. And this is becoming like more and more of a use case. Well, luckily in Airflow 2.0, the Airflow Stable REST API was introduced. And so what you can do is you can actually make, if you have a API key to the deployment that's separate from yours, you can actually make REST API calls to another deployment. And that's how we go about doing that. So right now right now I'm in my local host, which is just right here on my machine, on my laptop, right? And then we have another tab, and this is pointing to a completely separate deployment that I'm using. Now I do have a API key set up for this specific deployment so that I can make API REST calls to this deployment. And if we go to the Stable REST API Airflow documentation, there's a lot of different things you can do with REST API calls through the Airflow Stable API. The one we're going to be focusing on specifically, though, is the DAG Run, because with DAG Run, we can actually trigger a new DAG Run using these REST API calls, and if you have an API key for that specific environment. So after I'm done, in the use case example that I gave, after I'm done with my pipelines, at the end, I could put in a task to trigger the other Airflow deployment to start their pipelines. And so let's take a look at what that would actually look like in the code. So I've gone ahead and I've put together this custom module. And by the way, all of this code that I've been sharing with you and all of these examples, they are in the links. There's a GitHub. They are in the links that are provided in these slides. So if you wanted to download this code and use it or practice with it, you're more than welcome to. But I created a custom module in my sandbox here. So I have this utils Airflow API tools. If you were to clone that repository and take a look at these examples, if you wanted this custom code that I'm about to show you, it's right here. So what this does is I've gone ahead and I've went into my Airflow UI, and I've created a connection to the Airflow domain, I've created a connection in the Airflow UI that has the REST endpoint for the REST calls that I'm going to be making, as well as the API key and the password field. And what I'm doing is I'm just calling that connection, and I'm setting it up so that I can make REST API calls to it using the simple HTTP operator, which allows you to make GET, POST, patch requests via REST APIs and make that a task in your workflow. So as you can see, I'm using the Airflow API, I'm using the DAG Run task, and all I have to do is pass the DAG ID through this method right here after instantiating it, and that will allow me to trigger a DAG and an external deployment from my own. So let's go ahead and let's call this class into our DAG, specifically with the the connection string that I have set up, and I can show you what that looks like. So in our sandbox, I've gone ahead and I've configured this connection right here. And this has, if we go into here, the password field, which is not showing, which is by design, has the API key, and then I've set up the host. And if you look at this other deployment that I'm going to be triggering, right, you have that Amateur Cosmos 2865, that's the deployment name. I'm triggering that one specifically. Okay, so this is the connection ID that I need to call when I call that class. So from here, what I'll do is, as you can see, I've already imported that custom module that I've created. That's going to create those REST calls for me. So I'm just going to call this amateur. We'll name it after the deployment. And a lot of these deployment names are just random. So yours probably will be different than mine. But I'm going to call that same connection ID that I created in the UI. So if you remember calling that, I'm calling that Amateur Cosmos connection ID right there. And so that's what it looks like. So now I can trigger that DAG if I call it. So from here, let's create a variable, and we'll call this trigger dependent DAG. And I'm going to call that class and that submethod in that class. And this DAG ID has to equal the DAG that I want to trigger. And so going over here, I have the DAG called triggered by API unpaused for us. And I'm just going to drop that right here. Great. So that creates for us that class automatically creates a simple HTTP operator. So let's go ahead and go back to our sandbox. And we're going to trigger this DAG. But before we do that, notice how there's no DAG runs for this at all. Like it's just completely empty, right? And so when I trigger this, that should trigger that DAG that I'm referencing. So if I hit this trigger DAG button right here, looks like we got an error. Maybe it's because I didn't specify a dependency for it. Let's try it again. Try it one more time. I think the code was just catching up. Awesome, there it goes. Okay, so now let's go over to the separate deployment and hit refresh. And as you can see, it went ahead and it triggered that DAG. I just have a simple Python task in here that prints the current date. So if we look at that log, hopefully it loads. I need to up the resources on this deployment, honestly. It's not, sometimes I've been having issues with the log. But yeah, okay. As you can see, it triggered. But yeah, that's how you would trigger from one deployment to another.
That's a great example, Chris. And that was really, really good content. I know we just have 1 minute left, and we do have a couple of questions. So we'll try and get some of those answered. But first one I'll throw at you. How do dependencies work when using the task flow API? That was one thing we didn't cover today. I don't know if you have a quick answer. I can throw some stuff out there too, but
I don't have a quick answer, unfortunately. Do you have some resources that you could share?
Yeah, I would say for whoever asked that, just in general, if you have tasks defined using the API, so with the like Python operator using the decorator, then you can define dependencies by actually just invoking those functions and nesting them. If you have a mix of kind of Python operators versus using the decorator versus regular operators, then you would still have to invoke the function for your Python operator, and then you would set that equal to a variable and use that in your regular dependencies. So super quick answer, but there are some good examples out there. Cool. And then one last one, just in the last minute here. We have a question on when using the external task sensor, do you have to set a specific execution date and time, or is it possible to set like a range?
Let's see. Can you repeat that? I was trying to find the question, but I can't see it in the
yeah, it's a
QA.
little ways up. I'm kind of
Okay.
paraphrasing a little bit too. So using the external task sensor, I think they're wondering if there's a way to get around specifying an exact time for that execution date. So are you able to set like a range, or does it have to be like an exact match?
It has to be an exact match looking at the upstream DAG. And the reason for that is, I mean, you could have your upstream DAG could be running on 30-minute, hour, daily, weekly intervals, right? And the external task sensor just isn't smart enough to know what that interval is. And so you have to tell it which specific DAG run you're talking about.
Awesome. Cool. Well, I know we're at time. Again, Chris, thanks so much. That was a ton of information. Thank you to everybody for joining and taking time out of your day. As we said before, all of the materials that Chris went over will be sent out afterwards. And yeah, we hope you join us for the next one as well.